A model is anything that represents a real life situation. So a model can be a graph, a model can be an equation, a model can be a table. And that's what they did. They built a table, table 1.6, employment statistics. They built this table. So it says, according to that table, what has been the trend in males joining the workforce since 1954? So what do you think? It's going down. That's all you have to say. It's decreasing. It's going down. It's lessening. Letter B. In what 5-year interval did the percentage of men who were employed change the most? So what are you going to do? How are you going to answer that question? What are you going to do? Zach Bond, you got an idea? We're on question 12.
Yeah, I have part B. But, 1954. Isn't it like?
Well, 1954 would have the biggest percentage, but it said when did the percentage change the most?
Oh.
So when do we have the biggest difference? So like going from 54 to 59, it went down 1.2. But going from 59 to 64, it went down 1.4. So where is the difference the biggest?
Oh, 99, 2004.
Let's see, how much is that? 2.1? That's a 2.1 change, that's bigger. What about 69 to 74, that would be a, oh, is that 3.2? I almost did a calculator, we just got decimals, 3.2. What about 79 to 84? That's 3.3. I think that's the biggest. So, do you understand how to do that problem? So I'm assigning one tonight just like that. You okay with that?
Yeah.
Figuring that out? Okay, just takes a minute to figure it out. All right, number 20. A bakery sells a 9 by 13 cake for the same price as an 8-inch diameter round cake. If the round cake is twice the height of the rectangular cake, which option gives the most cake for the money? All right, so we've got a rectangular cake that's 13 by 9, and we have a round cake that's a 8-inch diameter, and this one is 2 times as tall. And we want to know which cake gives us the most for our money. They cost the same amount. All right, so what's your thought? That could be a problem you're faced with. I mean, you're gonna have a graduation party, hopefully. You're gonna order a cake. Which is the best deal? How would you figure that out? They cost exactly the same, so how would you figure out which one's the best deal? What does it depend on? What? Somebody said something, I just couldn't hear it. You're close. It's not really area, Moses. It would be volume. Wouldn't it be the actual quantity of the cake that you have? This is, I know I've drawn them, they look like 2-dimensional figures, but they're actually 3-dimensional figures. So think of having, think of the book here as being a rectangular cake. Moses? Don't we need length times width times height to tell how much cake we have here? So we need to find the volume of this cake. For a rectangular solid, that's length times width times height. You've seen that formula before. You're comfortable with that one. What do I not know? I know the length is 13 and I know the width is 9. What do I not know? The height. It doesn't matter. Pick whatever height you want. All we know about the height is, if this height is 1, this height would have to be 2. If you want to make this one 2, make this one 4. It doesn't make any difference. All we know is that one's got to be twice as tall. So I'm going to go ahead and use 1. So what's 13 times 9 times 1? 117 cubic inches. So if you go in and buy this cake, you're going to get 117 cubic inches of food. Now what about this cake? What's its shape? It's not like a book. It's not a book. What would I have to have? What would be the shape of this cake, this round cake that's sitting here? What do we call that shape? A cylinder. This is a cylinder. It's like this, right? There's our cake. What's the volume of a cylinder? Anybody remember that one? Maybe not. It's pi r squared h, where r stands for the radius. Remember, the 8 was the diameter, so this is going to be pi times 4 squared times 2. Where did the 2 come from? I let this height be 1, so this height has to be 2. Who's got a calculator? What's pi times 16 times 2? I got 100.53 if I typed it in mine. So if you go into the store, you're going to get 117 cubic inches of this cake. You're going to get 100.5 cubic inches of that cake. So if you're paying the same price, which one are you going to buy? The rectangle, because you get more for your money. It may not be as pretty or it may not be what you want, but you're going to get more for your money with this cake. Got it? All right, let's look at the first page of your new note sheets. This is some actual equations. And you're going to like this because a bunch of it is review. Thoughts on solving this equation? All right, one option would be to complete the square. Now, if you complete the square, you have to move the 1/3 to the other side, right? You're also going to have to deal with the fraction, because if you complete the square, you can't get rid of it. You're going to have to keep it. What number would I add to both sides to complete the square? 4? Now I need to add 4 and 1/3. Mr. Brokaw?
You have to get the same common denominator.
I do. So I'd have 1/3 plus 4 over 1, right? So I have to make this one a 3. So that's 1/3 plus 12/3, so 13/3. Which is not a lovely number, but it is what it is. Now what? Square root both sides. And as much yelling and screaming as I did on your test, some of you chose to complete the square on a problem, and that's okay, it's fine, you didn't have to, but you could. But if you complete the square, you have got to remember the plus or minus, right kids? You've got to remember that. If this is the method you're going to use, you have to remember the plus or minus when you take the square root. So x equals 2 plus or minus the square root of 13/3. Now, like I said, if you chose to do the problem this way, you're going to deal with that fraction. could I have times everything by 3 in the beginning? And then my equation would have looked like this. Now, if I did that, if I times everything by 3 in the beginning to get rid of the fraction, what would be my strategy now probably if I did this? Quadratic formula. Does it matter which way you do it? Nope. It's whatever you're comfortable with. All right, how about the next one? Oh, this is a big equation. What are your thoughts on this next one?
Subtracting FOIL.
What would I do first, Moses?
Subtract
What would I subtract?
the 5x.
All right, so Moses wants to get rid of this 5x. Now we'll FOIL. And FOIL stands for first, outside, inside, last. So first, outside, inside, last. Perfect. Now what? Combine like terms right here. And that's a -2 and a +1. Now what? Yeah, let's get it set equal to 0. So we're going to subtract x squared. So we're going to have a 2x squared. We're going to add an x. So we'll have a -8x. And add a 2. So we'll have +4. Now, was that too much? Did everybody follow all that? So now I've got this equation to solve, which kind of puts me where I was a minute ago. Because this is another quadratic, isn't it? What might you do with that guy if you wanted to? You might divide everything by 2. We never have to do that unless we're completing the square. But we might do that. Now what? Quadratic formula. -b plus or minus the square root. B squared minus 4ac over 2a. What is that, 8? And you know what? Again, as much as I yelled and screamed, some of you on your test canceled these. Can I cancel these? I know 2 goes into 4. I know that. But can I cancel those? No. You cannot cancel unless you have something to cancel in those 3 places. So am I done? What's the square root of 8? Doesn't that break down, gang? 2 root 2. So I have 4 plus or minus 2 root 2 over 2.
So you can
Now I can cancel. Can't do it here, but I can do it here. And there's your answer, because I took a 2 out of this, 2 out of this, and a 2 out of this. Now that is a lot of steps. I probably didn't leave enough room there for you. That's a lot of steps. But none of it's new, right, Freddie? We can do that. We take our time, we can do that. Zach Bond, the agreement, you think you can do that?
Yeah.
One step at a time, taking your time. Try C on your own there, or with your partner if you want. Try C. Think about what you should do to get started, So Jake's the only one out today. Claire, what'd you do first? You distributed. That's a great idea. That's exactly what I would expect everybody to do, distribute. What'd you do second, Claire? You completed the square because you said it's really set up for that, isn't it? With the 5 already on the other side. So what did you add? I can't hear you. What did you say? Yep, so you added 4 to both sides. Perfect. So x minus 2 squared equals 9. When you square rooted, did you remember to say plus or minus 3? So 2 plus 3 is 5, and 2 minus 3 is -1. Beautiful. Did anybody have a different strategy? Savannah?
I did the quadratic formula.
You did the quadratic formula. So you, when you started, you did your distribution. You distributed, right? But then you had to subtract 5. So it said equal to 0. Did you get exactly the same 2 answers? Good job. Anybody try anything different? Nathaniel?
I just factored.
You just factored. That's an easy factoring problem. If you like to factor and you noticed it factored, you can factor that pretty handily. And of course get exactly the same answers. All 3 options are there. Quadratic formula, completing the square, and factoring. Good job. One more, kids. How about that last one? What's your thought on that? I would set it equal to 0. You got stuff on both sides. Let's get it set equal to 0. So we have 4x squared minus 15 equals 0. Is that right? Jennifer, you got any thoughts on that? What we might do next? Actually, this is a perfect square. But is 15 a perfect square? No. When you have just 2 terms, you're looking for the difference of squares. But if you're going to have the difference of squares, it would have to be something like this. That would definitely factor 2x minus 3, 2x plus 3. Everybody remembers that? We've encountered that before. The 15 sort of ruins this because it's not a square. This would be perfect, but that's not. So I'm probably not going to factor this one. Could I use the quadratic formula? What would A be? What would B be? 0. B is 0. Because remember, when you use the quadratic formula, what's B? The coefficient on the plane X. And what are we missing in this problem? The plane X. So if you're going to use the quadratic formula, that's perfectly okay, but B is 0. What I might do, we did some of these. I might move that 15 over and take the square root of both sides. What's the square root of 4x squared? 2x equals plus or minus root 15. So x equals plus or minus root 15 over 2. So that strategy will work. You could also absolutely use the quadratic formula if you wanted to. Anybody have any questions about that? All right, then I want you to take out a clean sheet of paper, and I want you to get started on the following problems. Please work together, help each other. Oh, were there any questions about last night's homework? I thought they were pretty easy, but I'm the teacher, so I'm supposed to think they're easy. Anybody have any issues with the factoring problems I asked you to do last night? You need to clear up anything with the factoring problems? We're good on the factoring from last night? Okay, if you didn't do that, you better make sure you know how to factor those things, because that'll show up on a quiz or something. This is on page, oh yeah, that would be a good piece of information to know. This is on page 82. This is 1.1, it's page 82.
That's our homework tonight?
Yep. And I want you to get started on it right this minute. We have a little bit shortened the periods today. Not sure. You don't have a lot of time, but you have a few minutes to get started. So that's what I want you to do on